Hey there everyone, all the techies and data enthusiasts there. Welcome back to my YouTube channel. So guys, the wait is over. The most awaited and the most requested video, Generative AI Roadmap 2025. So guys, whether you want to learn Generative AI or RAG, fine-tuning an LLM model, difference between open source and closed source models, MCP servers, what the hell are they? MCP servers and A2A protocol, agent to agent protocol, so how they work, everything has been covered in this video. So from basic Python to till reinforcement learning, vision based languages and robotics as well, complete generative AI roadmap. It took approximately more than 1 week for me to clearly research and double check the topics and create a detailed roadmap. This is the roadmap which I'm going to explain today, and I guess the video will definitely be lengthy, but it will be worth it. And guys, make sure to do like, share and subscribe the channel and on the bell notification. And if you want me to teach all these topics, like if you want me to start this curriculum or a playlist based on this particular roadmap, you all have to just comment below generative AI. The more comments I get, the more interest I get. So I will start to record the videos very fast and release very fast. So let's see guys, I am expecting at least many comments and likes for this particular video. Approximately 1k likes is definitely. So please do smash the like button. Now let's get started. So guys, here's the roadmap, Generative AI Roadmap 2025. You can see here from the basic Python tools to till reinforcement learning, vision and robotics, everything is clearly covered in this roadmap. Apart from this, even we have created a GitHub repo as well, which contains the roadmap, what it is and all the phases what are covered here. All those topics are available here. You can just click on each phase, you can start to see how can you learn, like what all topics you need to learn. Everything is clearly mentioned here, and the timeline and tools, everything. So you can see the technologies we are going to use and the tools and timeline as well. So this is the basic timeline, how much time will it take to learn generative AI. So everything we will discuss one by one. So before that guys, just a small announcement. So this is a channel called AIQ Telugu, which I have recently started. AIQ Telugu YouTube channel. This is mainly for the Telugu speaking audience. So those who are from Andhra Pradesh, Telangana. So guys, and even others, those who know Telugu and understand Telugu, I am going to start teaching AI in Telugu as well to educate our Telugu community speakers. Apart from that, even I am going to very soon start a YouTube channel on Hindi as well and in Kannada as well. So based on the requirements, very soon I'll come up. But now I have already started a Telugu AIQ Telugu YouTube channel. So the tagline also AI నేర్చుకోండి మీ IQ పెంచుకోండి. So it's a normal tagline. I would request you all, please take some time, just check out the description. I have already added this channel link in the description, and do subscribe this channel and encourage me to teach you all or educate the Telugu speaking audience as well, those who don't understand English. So for them specifically, I have started this channel so that they can understand the AI concepts in Telugu, and even I can slowly take them towards the English channel, so I can educate them slowly, teach them even English terms as well related to generative AI. This is one step from my side. Please make sure to subscribe this channel. I know you have a lot of work, subscribe this channel, that channel, comment, but please guys, you have to do it. So everything will not be given for free. So when I am taking this much of efforts and creating videos, I expect this from you all. Please do it. Now let's dive back to Generative AI Roadmap 2025. So here you can see here Python and its tools. So first we will discuss about them. So all the tools and essential libraries what all are required, everything is clearly mentioned here in this basic Python only, including Git and other version control tools as well. Okay, this is very important. I'll explain you. So first we will start with the basic Python fundamentals, where you should start to learn the basic syntax, variables, loops, functions and modules. These are the basics actually, and OOPS concepts, and writing the file handling and exception handling. These all are some of the fundamental Python programming based concepts which you need to learn. And again, by just seeing this, you don't need to like think how can I learn based on this. So just go back here in this GitHub repo, just click on phrase 1. So in phase 1 you can see here Python tools and technologies. So learning objective module breakdown. So you can see here Python fundamentals, where you will be learning the basic syntax, indentation, variables and data types like int, char, float. So all these types are there, right? That and loops, for loop, while loop, range and enumerate, conditional statements, if, else, elif. So everything is clearly mentioned here. Functions and parameters, return statement, how can you write it, lambda functions. So input, output, file operations, try and exception handlings, and coding style like PEP8 and commenting, how can you do commenting and name conversions, everything will be detailedly taught here with some hands-on lab which you need to learn. You can see here, you have to learn this actually, not taught. This is the normal roadmap which based on this you have to start to learn. So use the ChatGPT help and start to learn, or else just comment below generative AI. I will soon start again the proper series, and this time it will be very clear. Based on this roadmap only I'll start. I already started a Python roadmap, or you can say Python lectures, but I left it in between because there were multiple tasks related to AI which need to be completed in priority, and number guessing game. So these are some of the basic projects you can do. After this, oops concept. So you can see here we have mentioned oops concept at the second, and you can see here that one, what is oops and why it matters, classes, methods, objects, so instances, inheritance, method overloading, encapsulation. So all these oops basic concepts is clearly covered here. Then how can you create a bank account system, like class based on bank account system, and implementing inventory management. These are some of the hands-on projects which you guys need to do. And Python for data manipulation. So after this, okay, file and exception handling is already covered there, okay, in those two topics. So that is where this Python fundamentals are done. Once you complete this, you're good to go with the libraries and their concepts. So how you can see them? So if you see here, the timeline is already fixed. For Python, you have to at least basic fundamentals is important. Machine learning, deep learning, later you can learn fast, but the fundamentals, Python, it will take at least 4 to 6 weeks, which is approximately more than 2 months. Approximately you have to spend 60 days of time to completely learn Python only, create projects and work on them. Then only you have to move to machine learning. So without spending time on Python fundamentals, if you directly move to machine learning, I'm telling damn sure guys, you will definitely be confused and the way of writing programs will not be clear. So this is an 100% clear instruction. Please spend at least 4 to 6 weeks on Python. Okay, now let's go ahead. Essential Python libraries. So once that's done, then start with NumPy, Pandas, Matplotlib. So you can see here 1, 2, 3, 4, 5, 6. So these 6 topics, 6 weeks clear. Okay, for each week you have to complete one fundamental topics, or it can go a bit up and down. That's fine actually. So because here when it comes to Git version control, this all you can learn within 2 to 3 hours or max 6 hours. So within one day you can complete, then you can compensate the time. So only I told 4 to 6 weeks. So this libraries which are there for data analytics and data visualization. So you have to learn these libraries. So again about these libraries you have it in this phrase. So this is the last time I'm going to show you this phase. Again, when it comes to machine learning, then I'll show you. So NumPy, you can see how can you create an array, broadcasting, slicing of the operations, reshaping arrays, mathematical and statistical functions. And when it comes to pandas, what is series and data frames, how can you handle missing values, filtering. So all these things should be detailedly learned. And this NumPy pandas, I have already created a dedicated clear video, 1 hour perfect video. So you can check out those videos in my YouTube channel, and I'll provide them the link in this video description as well. After this, some data visualization tools, Matplotlib, Seaborn. So I told you, right, like different plotting techniques, line plot, histogram you have, donut chart you have. So how can you plot them, pie chart? How can you plot them using Matplotlib and Seaborn? You have to learn about them in detail. You have to download data from Kaggle, practically implement them, then only you will be able to learn. Okay, some visualization projects you have to do based on them. Then Once you're clear with this, then you have to go with development and setting up environment. So basically, when you're going to start with Jupyter Notebook and interactive coding documentations also you can create. So Jupyter Notebook or Google Colab, your choice. Mostly if you don't want to set up, or your your laptop is uh, you can say not an high-end configuration, it has some lagging issues and it doesn't work properly, then go with Google Colab only. It's a cloud-based server, so you can easily start to type there, work on it. Your laptop will also support. If you have an high-end variant, go with Jupyter Notebook. Then VS Code and PyCharm, these are the IDEs, how to use them and how can you write code on them. You can just check out about them and understand about those IDEs, how can you use and utilize them, remote servers, GitHub, how can you connect, how can you fork a repo, everything you can understand in VS Code, downloading of extensions, everything. So just learn about them. It's all about these tools, okay? It will not take much time. Then Google Colab, it's a cloud based as I told you already, and even Google Colab provides you free GPUs as well, T4 GPUs. So which is temporary, like you can say approximately 8 to 12 hours in a week. So you can use that GPUs and train a high, or you can say train a kind of big data or million parameters data. You can provide to it and you can start to train and visualize on them. So you obviously know, right, when the data is very high, then the load on the system will be high. That time you can download and you can use them. I mean, you can connect with GPUs and use them. So that development environments, how you can set up, you have to understand that. So once that is done, Git and GitHub. Git and GitHub is must and should. So those who all are learning programming, not whether data science or generative AI or data analytics, if you are into programming, you should 100% know Git and GitHub. So in Git bash, how can you write the commands? These all are just normal commands, one line commands only. Git push, git commit, so all these are one line commands only. It will not take much time, 2 to 3 hours. So make sure to learn, and soon I'm planning to release a video on it as well. So if you want that, just stay tuned, subscribe the channel if you haven't already. So git bashes, or you can say git bash basics, where you will be learning git init, commit, push, pull, branch, and how can you rebase and how can you fork the branch, and GitHub repos. So this is also a GitHub repo, right? So how I have created this README file, you can see here. So I'll go back as well. How I have created this README file, how I have added these connections to it, and this tabular format and detail points, everything. So these all and added image, all these things, right? Try to learn, explore on them. So you'll definitely like feel GitHub very interesting, because it's all about one line commands and basic UI edits. Okay, so learn, spend time on Git and GitHub. After this, virtual environments. So once you're done with Python, right, in Google Colab, and you have understood the VS Code, Git and GitHub version controlling tools, next step is version controlling, or you can say virtual environment. Next step is virtual environment, where you mainly have to create a virtual environment in each project. So what is virtual environment? It is nothing but a virtual based environment, you can say, which you are creating, a VNV or a Conda based environment which you are creating for that specific project in a particular folder, so that whatever libraries you are installing, everything related to that project will only be saved on that particular virtual environment, or in that particular folder only which you have created, virtual environment folder. So it's like you're creating a cloned version of your Python, so that you can work with it, you can install all the libraries for it. The main advantage of this virtual environment, right? One, you are using Python version 3.13 or 3.12 in your main laptop. So if there are some unsupported or old packages which require 3.9 and 10, doesn't support 3.13 or 12, then you can use virtual environment, create a 3.9 Python workspace or a virtual environment, where all the libraries will be installed for specifically to 3.9 only, all the packages. Okay, so you will be working with 3.9 Python environment there, but your main system will have 3.13 or 12. So here you are just creating a cloned version of Python according to your requirements. And two, the main important thing is, see, if you don't create a virtual environment and directly install any libraries or packages in your local system, the main problem is, See, for you will be working on multiple projects. For one project, a different package requirement will be there. For another project, one more different version package requirements will be there. So when you install for this, that version packages which you have previously worked on project, that might get deleted and that project will not work later. For now, this will work. How many days will you sit and solve the conflicts? When you go to that project, there again install everything. When you come to this project, install everything. So that is an hectic task, right? So to overcome this, virtual environment for each and every project is mandatory. So make sure to know about it, and if you want me to explain in detail about virtual environment or create video on it, so comment below VENV. I will definitely come up with a short video on it, some 5-10 minutes video which you can easily understand about virtual environment. Recommended tools and platforms. So obviously these are the tools and platforms: Google Colab, GitLab, or GitLab is obviously required. So I mean Git and GitHub, and Jupyter Lab, Jupyter Notebook is there. Based on Anaconda, you can install that. VS Code, PyCharm. Okay, so all this Anaconda, all this you have to install, excluding Google Colab. This is available on your Google itself, Google Drive. So that is not required. It's a cloud based. Apart from that, all this you have to install, and GitHub, for that you have to establish connection. Then you need to install Git, obviously. So these all are the tools and technologies which you have to learn within another 4 to 6 weeks. Okay, this is for Python. Once you're done with Python, next machine learning. Okay, let me close all of them. So, okay. Okay, for machine learning, step by step, let's come. First, data analysis fundamentals. So once you have learned NumPy, Pandas, Matplotlib, Seaborn libraries in your Python tutorial, then you're already like almost 50% aware, 50 to 70% aware about EDA, exploratory data analysis, and visualizations as well. So you have to learn EDA mainly. Take the worst, in a sense, worst data set, do data cleaning, handle the missing values, create the data into a proper structured data which will be suitable for visualization, find out the insights from it using the plottings, like you can plot with scatter plot, heat maps, histograms, and bar graphs. So you can plot all of them, create a plottings based on the data, find out some insights, whether it can be, if you are handling a bank based data set, so how many customers have taken the credit card, how many customers did not take, what was their limit, and who is spending highest, who is not spending. So the customers who are not spending, because of whom you guys have to provide offers, and who are spending very high, for them what all benefits you can give, if you can increase the credit limit. So all these questions, right, as a data analyst or a machine learning engineer, you should have it in your mind. First you should start to answer these questions, or you have to create all these questions based on data, and for these questions you have to find out the insights. That is one of your main task here. So for that you have to learn all these three. You have to learn EDA, data cleaning, missing values, histograms, scatter plots, and heat map. Statistical and mathematical concepts. Obviously, when you are into data science or AI, statistics and mathematics will definitely be there. So those who are scared of statistics and mathematics, please stop the video, try for 2 minutes, then again come back and watch the video. Okay. So guys, statistics and mathematics, for this, right, mainly you have to learn some basic concepts. You have to learn, that is probability and distribution and hypothesis testing. So you have to learn these concepts mainly, and also you have to learn linear algebra, where vectors, matrix, and probability distribution, so only probability comes into picture. Then you have descriptive and inferior statistics, which is important. So on statistics also we are planning, like I'm specifically planning a complete playlist. So let us see, like based on the comments I'll decide whether to do that fast or not. So make sure, go ahead, let's see. And gradients and derivatives, so these all things are some of the concepts which you need to learn. And before coming to like core data science statistics, right, I would recommend you go to your 10th, go through your like whether it can be 10th or 11th or 12th grade mathematics textbooks. Just learn linear algebra, sets, and then probability distributions, hypothesis testing, and all things will be here in statistics covered. So just learn those basics like vectors, what are vectors, and then you can come back and watch the core statistical videos and you can learn based on them. After this, again based on them, already there is a detail map here, I guess. Machine learning, yeah. If you click on this, you can see here probability and distribution. So basics of probability rules, distribution, Poisson distribution, descriptive and inferior statistics, linear algebra, calculus. So all those things you have to learn. So matrix. Okay. After this, machine learning foundation, where you have to understand the different types of machine learning. We have 4 types actually: supervised, unsupervised, semi-supervised, and reinforcement learning. So you have to understand all of them. Reinforcement learning, after this you have like train test data splitting and what is overfitting, underfitting in machine learning mainly. So you have to understand them. Overfitting and underfitting, based on the data you will get this normally. Bias variance trade-off, so how you can solve all this when the data is biased. So you have to understand all these concepts, and those concepts are already available here. You can see a machine learning types, and you have the core concepts like train test split and the validation, overfitting, underfitting, bias variance trade-off, how it mainly works. Everything is detailedly explained here. Then you have the key algorithms. So once these are done, then you have the libraries, you can say libraries or packages which are already available. So regression based libraries, which are linear regression, polynomial regression, regularization like L1 and L2 regularization techniques. So you have to use those algorithms and train your model with the help of the dataset, clean dataset which you have created, and create the model. So how that works, clearly you have to understand how the training goes, and if there is like after this, even the accuracy also matters, which comes in the evaluation techniques. I'll talk about them. Then classification. So regression and classification are two types, actually two types of data which you will normally have in machine learning, where regression is mainly used for continuous data like price. So price is not like you can say like 2 or 3 normal prices, 2 or 3 variables which are very common or repetitively you can see in a particular column. So it is like continuous data, like each house price can be different, a dish price can be very different. So then regression will come into play. Classification is mainly for any 2 or 3 selective categories, like categorical data you can say. In that categories, classification will help you, like whether a person will get loan or not. So here only yes or no, based on the criteria, like based on his bank balance, based on his EMIs, and based on his civil score. So all these categories you will take, then finally you will say whether yes or no. The output should be only yes or no. At this particular situation, you use classification based data. Okay, so for that you have logistic regression, decision tree, random forest, SVMs. So okay, so based on all this you can do. Then clustering. Clustering is another type where the data, like in regression and classification, you will have a target column. What is the target column? What you need to do, you will have a clear idea. When it comes to clustering, here the data, these are actually unsupervised algorithms, and here the data is not that clear. What is your target column only you don't know. You have to find out that, you have to cluster and bring them to supervised, or you can say find out the target column and create the target column based on this data which you have, and you have to then perform supervised training. Okay, so that is one. Or you can even use reinforcement learning, reward based. So you can even do that with the help of clustering or unsupervised learning techniques. So key algorithms are them, like then after this you have evaluation techniques of models, where you have metrics like accuracy, precision, recall, F1 score. So you have to understand what all are this. And accuracy, sometimes you will see 99, Sometimes you will see the accuracy is 100% or 97%. So when you see that, it is not that your model is 100% perfect in the first training itself, the model is overfitting here. So you have to validate properly why you are getting that particular accuracy and find out. So this accuracy term will come in AI and LLMs as well, obviously. Then after this, confusion metrics, ROC and AU score. So we'll be discussing about that, or you can say you will be learning about this confusion metrics clearly, cross validation and hyperparameter tuning. So all these concepts are very clearly discussed, so you can just go and check out there. So for this machine learning, right, you have some libraries here, or you can say packages as well. sklearn, or you can say even some of the engineers will call it as even scikit-learn as well. Scikit-learn and sklearn, so it depends. So this scikit-learn is a package where you have all these algorithms which we have discussed till now, right? All these algorithms or libraries available. So using scikit-learn, you can call all those packages, you can train the model, and even you can even do predictions, evaluations, everything using scikit-learn. It plays a very crucial role in machine learning. And apart from that, you have even PySpark, Dask, some other libraries as well which you can use, but mostly scikit-learn is 100% used. And for visualization, you have pandas, seaborn visualization, and EDA in short. Pandas, seaborn, matplotlib, and data manipulations as well. So these are some of the tools. And after this, once you are done with this, the machine learning is clear. So the timeline for this, you can see here, 6 to 8 weeks. Again, for machine learning, you have to create an end-to-end project, production level project in machine learning, then only move to deep learning. So don't directly jump into deep learning. This is my main suggestion. So slowly the more the difficulty goes on, the weeks will get increased, and it completely depends on the user's mindset. So some of them will be like don't even know programming knowledge and they want to start from very basic. Then for them this timeline is fine. Some of the students I have personally observed, they complete within 1 month the complete machine learning, and within another 10-15 days end-to-end projects. So because they dedicate mostly 4 to 5 hours a day, so if you are in that category, for you mostly 4 to 5 weeks is enough. Okay, let's go forward. Next we have deep learning. And before that, you have MLOps deployment, which is completely optional, guys. So this MLOps deployment, if you're going to, or if you are the person who likes mainly machine learning operations, or you can say a kind of cloud-based works and monitoring, continuous integration and monitoring of the models, then this is for you. But when you are a beginner, MLOps is mostly not for the person, and moreover, MLOps engineer hirings, or you can say MLOps engineer main role will start after 3+ years of experience only. So those who are going to hire, they are not going to hire MLOps freshers actually, because in cloud no one is going to directly give any person, because if a small mistake it will be very high costly actually. So MLOps will start only after 3+ years of experience. You can, but to learn it, MLOps will be very interesting actually, working with cloud based technologies, deploying your model on live, and checking the continuous integration, experiment tracking. It is definitely going to be damn interesting actually. So integrating DevOps principles into ML workflow, like DevOps in short, if you know DevOps, where you have like Kubernetes, Jenkins, all these tools and technologies you will be using and integrating right to the software product. Here for machine learning workflows, we'll be using them. So MLOps lifecycle, you can see a development, deployment, and monitoring in short. So developing a model, deploying the model, and monitoring it. So monitoring the performance. Each time the best new model comes compared to the previous model with better accuracy, it will be auto deployed, and the old models will be discarded, or it will be stored in logs for the validation purpose. Tools, so you have some of the experiment tracking and version controlling tools. So in ML also obviously you have to do version controlling, rollback. So for suppose some model got deployed which is not performing well compared to previous model was working well, then you have to obviously roll back the version, right? So for that it will be helpful, version controlling. Tools, ML flow And weights and bias, so MLflow is a package, and even you have their library as well, so you can use MLflow and write. You have their own UI as well, you can check out about this. Weights and bias is another company, so where you can, it will be used for experiment tracking again. TensorBoard was introduced by Google, so you can use that as well for experiment tracking and rollbacks. So you can see here, what is your main target? You will be tracking the metrics, model versions, parameters and data sets, and comparing the runs and reproduce experiments reliably. So for all these tasks, you mainly use version controlling. After this, model deployment strategies. So for model deployment, obviously you need to deploy them as an APIs. Mostly we will deploy our products as APIs which are written in Python. So those APIs, right, you can write it on REST API. So you can use all the REST API services, whether you can use Fast API, Flask, and even Django. So for more convenient, right, you can use Django as well. In Fast API and Flask, you have to configure the file structure, you have to write everything, show everything. But here in Django, most of the things are pre-configured. You can easily start to write the code. For production level, I feel Django is more better because of our security and vulnerability detection. Most of the things are already sorted in Django. That is my favorite tool actually, or my favorite algorithm or IDE. You can say anything, like where I used to normally write and build REST APIs mainly. So here, Fast API and Flask also you can use it. If it's a microservice, then you have to go with Fast API and Flask. All the things are normally used. And interactive apps, how can you use Streamlit and Gradio and build a UI? So you don't need to actually sit and write HTML and CSS, because it's not our work as well. So for just testing purpose and you want a temporary UI or ready-made UI to be available, then you can use Streamlit and Gradio. Deployment strategies, so you can use cloud, which is Azure, AWS, GCP. So there only you have to obviously deploy in, and you can deploy it on EKS, EC2, and in AWS you have Fargate. So you can use any of them. Compute instances also you can use, and you can deploy them. And in AWS even you have Lambda as well. So you can use all of them. And on premises and on demand servers, you can take them and you can deploy. Okay. So these are some of the deployment strategies. And CI/CD for machine learning. So automating data pre-processing, model training and validation. For this you can use CI/CD actually for automation of this. Continuous integration and continuous development, CI/CD full form. So tools you have for this, you have GitHub Actions, DVC, Jenkins, and again MLflow pipeline. And even there is CI/CD only separately, a website and a package you can use CI/CD, and you can even deploy there as well. So these are some of the tools when used. Why CI/CD will help you, like I previously told you, right? When the model, so suppose now the model is running with 75% of accuracy, the model got some new data, then it will retrain by itself, and now the accuracy is 85% compared to previous model. Now the accuracy is better. So what the model will automatically do, it will automatically deploy this better model, and this better model, 85% accurate model is there, right? That will be served to the users for better performance and for better accuracy on the answers. Okay, then this 75% accurate model, right, that will be stored as an, what you can say, like backup. By any chance if this model is not working, then that will be used as a rollback. After certain time, this models will be auto deleted. This is complete automation script which we will be writing. We'll be writing YAML files for this. Okay. Okay, so yeah, these are the things. Then you have monitoring and logging. For monitoring and logging, like for detecting model drift, performance decay or errors, you can use. And the tools are Prometheus, Graphena is one more model, and custom dashboards, human in loop, back feedback and audit trials. So based on the human in loop, like you come in, like one human will come in picture, they will test the models and they will audit the model and do some feedback trials. Based on that, monitoring and logging also goes on. Okay. Tools and platforms are already explained. So MLflow, weights and bias, Hugging Face, Spaces, you have Docker, Kubernetes, uh, Google Cloud, Azure, Streamlit, Gradio for demo interfaces. So this is complete MLOps model deployment. Actually, this is an optional, but I recommend you to learn. This is already included with machine learning. So you don't need to specifically give timeline for this. When you are learning machine learning for 6 to 12 weeks, this is also covered in that. And if you want to see how this can be learned and what all tools, so just, yeah, here you have this separately here. So we will just click on this phase 3 and you can see all of them here. So what is tracking and tools, everything like REST APIs, everything is clearly mentioned here. You can just check them out. Obviously the video is becoming lengthy, I do accept that, but just stay till the end of this video. Then deep learning models, so you have to start with basic neural networks. So where you have to learn the perceptron, activation functions, ReLU, sigmoid and softmax, and forward propagation and backward propagation as well. Loss functions like MSE, cross entropy. So all these concepts you need to learn mainly. Perceptron, or you can say the first neural network is there, right? So you have to learn about them. Then comes in the architectures where you have to before all these architectures, ANN, Artificial Neural Network, is one of the important architecture which you need to learn, and that is the first architecture in neural network space which was introduced. So make sure to learn that. Then start with CNN, Convolution Neural Network, which is mainly used for image classification, feature mapping, and pooling. Then RNNs and LSTMs, these are mainly used for sequence modeling, time series data, and even for audio based data as well. These are sequential models, one word at a time. So sequentially data will be processed, input and output both. Transformer based model. So transformers, when it comes to transformers, you don't need to think anything else. It's an ultimate beast actually. Google has released transformers in the paper called Attention is All You Need from Vasavini, a person from Google only. So Google DeepMind. So he is the person who is behind this tech. They have released this on 2019, I guess. 2019 when they released transformers, it's a game changer, you can say. Because of transformers only, now all the ChatGPTs and other open source models like Llama, Meta, Mixtral models, generative AI models, which you all are seeing, right? The main base is this particular transformer based architecture only. So without this architecture, AI is nothing actually. So for this, we have to actually thank Google for this such great research, and because of which we all are able to revolutionize the tech. Google has so many of these things already, but still I don't know why Google is lacking behind in the generative AI space, which I personally feel, where Microsoft and you can say OpenAI and Apple obviously they are using OpenAI only, nothing more than that. So when these all companies are already revolutionizing, and Meta, obviously Meta is the ultimate beast here. They are releasing all the open source models, perfect models actually, which you can use on your server, fine tune them, use for your business use cases. So when all these companies are coming up with great inventions, why Google is lacking behind, I don't know. They are inventing, but what they are inventing, I guess it's more ethical, and it is used for the, like, mostly for business use cases, I can say. Optimization and regularization. So for optimization, you need to learn SGD, stochastic gradient descent, Adam optimizers, RMS prop. So these are some of the optimization techniques. So you have to learn about them. Regularization techniques as well, dropouts, batch normalization, and weight decay, learning rates and gradient capping. How can you do gradient capping, and learning rates? How can you add the proper learning rates based on the model? It's all about trial and error. So you have to learn all this optimization and regularization techniques. Then the tools and framework. So here you have TensorFlow and Keras, which was released. TensorFlow was released by Google, and Keras also internally supports for it. PyTorch was released by Meta, and for dynamic computation it is mainly used, and it's the ultimate beast here, PyTorch. Because of PyTorch only, now all the GPT models and all the open source models, closed source models. So compared to TensorFlow, we actually, PyTorch is very good in writing all those um, big LLM models actually. Then Lightning, you have Hugging Face for production ready tooling, so you can use all of them as well. So you have Hugging Face library. Also you can import transformers and everything, what all models you want from Hugging Face actually. Training and evaluation. So after this, once this is done, then you have to understand the data processing for deep learning, like whether it's image or text, and how many epochs are nothing but how many iterations you want to do the model, or you want to train the model. And batch processing, how many batches you want to send the data, overfitting and underfitting of the model, visualizing the learning curve, which is loss and accuracy of the model. So this is training and evaluation which you need to do for the model. Once it's perfect here, then it's 100% clear. You are clear here, right? Compared to data, you are using something like a neural network based models, and you're teaching the model. In short, when it comes to machine learning, there how it happens, you give the model data, the model builds is you are building the model, then finally deploying that model, you're serving the model, that's all. But when it comes to deep learning, here neural networks are nothing but they mimic the human brain. Like how we have the brain, neural networks are designed in such a way so that the LLM models or even the NLP models, whatever are there, they have to understand the data you're giving the model and you're training them, so that the these particular LLM models can understand and they can feed in themselves and they can save themselves, like whatever questions you ask, based on that it can answer. Okay, so that is there. And the best practices, data augmentation techniques, transfer learning is ultimately the beast which saves lot of time and resource actually. And with pre-trained models, that is mainly used, model checkpointing and callbacks as well. So these are some of the deep learning tools and technologies and the algorithms which you need to learn. And for this again, you ultimately have 8 to 10 weeks. So this is an for complete fresher. If I'm imagining you as a fresher, then I'm telling you, but it can go up and down the timelines. Okay, so yeah, and for that it's already discussed. Then we will go forward with core generative AI techniques. So finally guys, we are into generative AI techniques. Now here you will start with what the hell is generative AI or Gen AI. So you will start with the models, like basic models that generates the content, whether it can be text, image, code, music and videos. What are they and how they are generated by the AI models? Like you can take example of ChatGPT, how it is actually answering that perfectly for your questions. So you will understand them. Contrast with traditional predictive models, so you'll compare them with the traditional predictive models, how they are able to perform well compared to the traditional machine learning models which you have built, that you will be learning here. Transformers architecture, a deep dive into transformers architecture and transformer based models. So the GPT is transformer based model which was obviously released by OpenAI. You all know GPT-2 is actually open source, so those who all don't know, you can fine tune that model and you can use it for your business use case as well. But T5 and how attention mechanism works, encoder decoders architecture. So these, right, transformers, I have created a complete playlist on transformers. You can check out the playlist link is in this video description. A complete architecture has been explained. So main use cases of transformer for summarization, translation, question answerings and chatbots. Okay, you can build all these use cases. Diffusion based models, where you get forward versus reverse diffusion process, in which you have stable diffusion obviously, and DALI models, how does DALI works, mid journey works, and stable diffusion based models are there, how they work, generators and GAN based models are there. Applications, text to image generation, for text to image generation, in painting and style transferring. So for all this you can use, okay, you can build the models actually, you will learn. Then prompt engineering. So prompting types, zero shot learning, few shot learning, chain of thoughts, designing prompts for creativity, reasoning and controls. For this you have tools like OpenAI Playground, Hugging Face interface, and even you have Meta as well now, meta.com. You can directly, meta.com or .ai I guess, you can directly open and you can start to chat with it. And multi-models, so when it comes to multi-models, you have the models that can handle both text, image, and some models with text plus image as well. So text, image, audio, all these capabilities will be there for model. When the model can handle more than one task, text plus audio, text plus image, or image plus audio, then these are called multi-models. Here you have SCLIP, BLIP, and GPT-4V. Okay, so we'll be discussing about them, or you can say you will be learning about them. Vision, language alignments, and retrieval tasks. So all this, right, are already clearly given here. Transformer based, you can see attention mechanism use cases, diffusion based models. So forward process, add noise to the data, reverse process, how the model denoising the step-by-step process. So you will be learning about them. Generating effectively generate from scratch. How can you effectively generate an image from scratch? Prompt engineering, prompt designs and tools, multi-model. So you can see here what you need to learn. Everything is vision-based model, right? GPT-4 Row and language plus prompt models, use cases, everything will be detailed. You have to learn them. So all the detailed roadmap is available there. Evaluation metrics in generative AI. So you can use text like BLEU or Rogue and Meteor. For image, you can use FID and inception score. For human evaluation, you can use coherence, relevance, and creativity. So these evaluation, right, the one of the main problem in AI is only model evaluation. So it is very difficult to evaluate a model because transformers or any models after transformers which are released, they are black box models. So what they understood, how they think and how they generate, that no one knows actually. So it's very difficult, but even you can still using LLM ops, some like you have OPK tools, using them you can do experiment tracking and you can do evaluations also, and these are some of the methods of evaluation which you can do. So that techniques you need to learn. Model capabilities. For text generation, you have Claude, ChatGPT, and obviously Perplexity. Code generations, you have Codex, GitHub Copilot, image generation, DALI, SDXL. So and even Mid Journey, you have Leonardo.ai. Many image generation tools are there. You have for image or no, for music and audio generation, you have AudioCraft, Music LM, 11 Labs, and I guess yeah, Fish Audio. There are multiple audio based Gen AI models as well, which you can use and you can try out them. Then advanced generative AI systems. Here comes the core learning of generative AI, fine tuning a large language model. For this, you have LoRa, QLoRa, PEFT method, parameter efficient fine tuning, and full fine tuning was a transfer learning. In LLMs also you can do transfer learning. How can you do that? That will be discussed. Tools like Hugging Face, PEFT you can do, and bits and bytes, Llama CPP you can use. So how can you fine tune the models with all these techniques you can. So most of the time I observed was LoRa and QLoRa was perfect in fine tuning an LLM models. So you can just give a try about it and you can learn on them. And obviously if you want to fine tune in Google Colab, use Onslaught. Okay, Onslaught AI is very good for it. Advanced training techniques, you have reinforcement learning, human feedback evaluation based on that. So model will be a reinforcement learning model, but based on in human feedback it will improve. DPO, so direct preference optimizations are there. Instruction tuning for task specific behaviors. Convolutional, or you can say constitutional AI, which is from Anthropic, that will be helpful. Sorry, constitutional AI it is. Then RAG, combining LLM with external knowledge, that is called as RAG. Normally you have to understand that. For this, how the embedding of models work, you will be learning that. Vector stores like Fayaz and Pinecone, and even you have Quadrant, Melvis. There are multiple vector databases right now. You can use even MongoDB as well. So how you can use them, how can you embed the data which you have, you can embed them and upload in this vector database, and how can you connect this vector database to LLM model so that it can fetch the answer based on your question, context aware and fact rich answers. How can you get them? So that you need to learn mainly. Already I'm doing 25 types of RAG series. You will be seeing them very soon. Already 3 videos are live. If you haven't, you can just check out a very interesting videos. Okay. AI agents and multi-agent system. Here you will be learning Gen AI agents like Baby AGI, AutoGPT, and you have even Crew.ai. Multiple agents are there. Crew.ai, AutoGen. Okay, and architectures like you have reactive and deliberative BDIs. For communication protocols, you have A2A protocol and MCP, model context protocol. So MCP and A2A are the trending right now, using which you can actually LLM model can actually understand and it can complete the task for you. These are agents actually. So already I have created a video on GitHub MCP, not a core MCP. Core MCP playlist I already planned. So all the content and alignment is ready. I'm planning to record a playlist on it. You will be soon seeing that. A2A protocol, agent to agent protocol, which was released by Google. I already explained that. That video is also available in the channel. Check out a very detailed video. So where we are not going to use a normal UI at all, we are directly going to take their GitHub, clone the GitHub and configure it locally in our system, and also do some customizations and run that live in our system. That I have taught in A2A protocol. So you can check out that. Capabilities, memory, planning, tools to use, feedback learning. So all this you need to learn actually. So that is why I'm telling you all, if you want a complete series of playlist, a complete playlist of generative AI, somewhere around 100 hours, you can say 100 videos, more than 100 videos are required to cover generative AI. So if you want them, comment below generative AI, you will soon see the videos. Then application areas. So application areas you can see here where it can be used for code generation, bug fixing, testings, and for scientific like drug discovery, for protein flooding. For creativity, art and music you can use, storytelling, designer tools. Okay, so these all are the applications where you can use. Ethical and alignment and AI safety, bias detection and mitigation. So one of the key concept is your LLM model bias, that you have to check. If it is bias, make sure to retrain the model and refine tune the model and create a proper and bias free model. That is one of the main tasks. Based on evaluation, we'll get to know. Red teaming and adversarial testing. So you need to do adversarial testing, like for suppose same question you have to ask 100 to 200 times to a model, to get a proper answer. So many times it is giving the same answer. Based on that you can evaluate. That is one of the evaluation technique. Transparent and interpretable Gen AI technique. So you have to even work on that and understand the safety or measures of AI. Unethically you cannot train the model. That is one of the key concept. If you do it, it's considered as illegal. Tools and platforms, Hugging Face, Transformers, PEFT for fine-tuning, LangChain, Llama Index for RAG and tools of agents, weights and bias, TensorBoard, MLflow. You have OpenAI, Cohort, which is nothing but Anthropic APIs for instructions tuning for LLM, Fayaz, Pinecone, ChromaDB, and Quadrant for vector databases for RAG, MongoDB as well. AutoGPT, Baby AGI frameworks for agent orchestration. Okay, so these all are the concepts which you need to. Finally, once these all are done, then you are a pro in generative AI. After this, you have to work on some specialization like domain specific applications. You can say specializations and projects. Here, where you have some domain specific applications which you can, like healthcare, for healthcare, medical text generation, image analysis, clinical analysis. For this use cases, you can build the AI models. For finance, risk modeling, fraud detection, market summarization. For education, personalized tutoring systems, content creations, entertainment, game design, storytelling, music generations. So these are some of the applications, okay, where you can. Full stack Gen AI system architecting Gen AI applications with front end, back end, and model layers. You have to understand that API development and real time interactions. How can you develop the APIs, and how can you deploy to the front end, like whether it can be Copilot or chatbots, how they are gonna work. That you need to connecting Gen AI with tools and external data sources. How can you, in short, like how can you use OpenAI key and implement it in a code form? How can you connect it with your application? So those closed source APIs, how can you, if you're building your own model, how can you do that as well? ML ops in production, which is nothing but LLM ops, building reproducible pipelines, data model API. Life cycle is simple, your versioning, testing, updates. So model life cycle management. Deployment strategies, cloud, edge, and on premises. Okay. Research and innovation, you have keeping up with SOTA models, which is Gemini GPT 4o, Claude, Llama 3. Yeah. Exploring papers, benchmarks, and challenges, prototyping with new ideas and open source models. So if you have any open source models, you can create projects on that as well. After this capstone projects for development, you have real world projects which aligns to your requirements. You have to build them, end-to-end pipelines, data modeling, inference pipelines. Soon I'm going to create an LLM ops roadmap as well. Don't worry, if you want that, comment below LLM ops. Obviously guys, I'm telling so many times comment, because based on your comments we get video engagement and even the channel can grow up. So please do comment. Document and present, blog post, demo app, and GitHub. So you'll be discussing all the GitHub repos which you can. Tools and resources. So all are these tools which I'm again not gonna say. So paper with code, Wax you have for researching, Systematic Scholar for research, Hugging Face, OpenAI, Gemini models, Docker, Kubernetes, MLflow for production deployments, LLM ops in short, LangChain, Streamlit, Gradio for building an end-to-end Gen AI application. So recommended to just check out this GitHub repo, you will get it very clearly, okay? And timelines for generative AI fundamentals 8 to 10, advanced 10 to 12. Finally, specialized projects, again you have to spend another 4 to 8 weeks max. Reinforcement learning and vision language and robotics for this. So reinforcement learning, you have core concept like agent, environment, policy and reward systems. Algorithms, you have Q-learn, DQ-learn, and DQN learn, and PPO. Applications in Gen AI, so reinforcement learning from human feedback. These are main reinforcement learning concepts. Vision language integration, so vision based multimodal, which is text, audio, and image together. Notable models, generative AI 4.0 or 4.5, I guess, which has Flamingo, and you have Gemini and BLIP2. So these are some of the notable models. Use cases, vision question answering, document understanding, image grounded chatbots. You can build all of them. Robotics and embroidered AI. So connecting Gen AI to the real world sensors and authenticators. This is very advanced actually. If you want to build an embedded systems, robotics embeddings are models actually. We do model data embeddings right in RAG, so that I got it. But embedded AI systems, if you want to build, you have to learn embedded systems robotics as well. Use case AI assistant, warehouse robots, autonomous agents, which already many big tech giants and companies are building out. Sensor fault for sensor fault detection, control systems, and spatial reasoning. Research exploration. So for this, you have like breakthrough, like research papers you need to read in short, track data sets, leaderboards, and open challenges. Experiment with low code plus pre-trained plus domain datas and build and experiment them. Tools and platforms, here you have again OpenAI, Gym, RL, Lib, DeepMind, Control Suite, Hugging Face Transformers, and all these models. These are normally which you will be getting them in Hugging Face spaces. So you can start to explore them. Okay, so that's all guys. These all are the roadmap and these all are the tools and technologies which you need to learn if you want to become an generative AI engineer or a data scientist who is right now working on AI as well. So I hope after seeing all this, either you are more excited or you are more depressed. So if you are depressed, no problem. Take your time, slowly learn till at least complete NLP, complete till NLP, get into data science field, learn AI technologies slowly, then get into generative AI field. So that is important. So you have to learn. It's all about learning and gaining knowledge process. So in this, even I don't know this robotics mainly, actually robotics, vision based modeling, so all this I don't know. Even I have to learn. It's very interesting actually. Quantum computing also I like it. So we need to learn. It's software field or gen AI or AI space is continuous development and continuous learning process in your entire life. Software, in essence, you have to continuously learn, develop yourself and create projects, gain experience on that particular task. The more faster you learn, the more edge you have on the latest technologies. So remember that it is not when you start, it is at what time you are starting. Now AI is in boom. After 10 years, if you start all these technologies, it is no use actually. Now it is in boom. This is the right time to start. Invest your time completely on this. Learn properly. And obviously, if you know AI, no one can replace you. Even AI cannot replace you because you have an edge on it. You are the core creator of it. If you don't know that, then might be your jobs might be replaced by AI. So replace in a sense, it is not going to completely replace or automate, but where we require 100 engineers to work, now only 10 engineers are enough. So the requirement of job will gradually decrease. That is the point here. Those who learns AI will have an edge here. Okay guys, so I hope you all understood this. The video is 1 hour long, complete detailed roadmap. I hope you all got the clear picture. If you have any questions, ask below on the comment. I'm open to respond. So guys, that's all for today's video. Do like, share and subscribe the channel. Meet you all again in my next video. Bye bye.